the couple that I have. So I'm going to try to cram quite a bit into today. I had put on this sheet that I would come tomorrow morning and kind of give you a heads up on your quiz that's scheduled for tomorrow. But I think that we can get it done today, and then we don't have to do this tomorrow. I just had a different quiz in mind. It gets kind of confusing when you think about the week that you're in and the week that's coming up, and it all just kind of jumbles together. So I think that in light of the review that we're going to go over today, that we'll have time to go over the quiz for tomorrow as well. Okay, so let's start with that then. So on the quiz number 28 is the one that you're supposed to do tomorrow. It's a lot of the same stuff, knowing how to use sine, cosine, and tangent. Obviously, that's kind of a mainstay in what we're doing. Also being able to use the Pythagorean theorem. You would want to use that in a scenario, say like where you don't have any angles given. If you're only looking at lengths, then obviously you would have to use the Pythagorean theorem. You also are going to have to answer some questions based on terminology that goes with word problems. So like the distance from here to the camera, in a right triangle, you would just have to like mark an X, at the right side of a triangle that would depict, or an angle of inclination, that would be an angle looking up. Okay, so just little things like that. You do have 2 word problems on the back that you're going to have to make right triangles, but they're very basic. They weren't anything like the more complex ones that we did in that assignment. A little bit of a gray area. Let me just go ahead and give you a heads up on one of them. So on number 3, you will find on your quiz tomorrow, the problem is a word problem that's given to you. And what it's pertaining to is a cable or something, a zip line that drops from one treetop to the other. Okay. Now, what I want to make clear to you, because it's not clear, when it says that the zip line drops from one tree top to the other, it's talking about dropping straight down. It's not talking about a slant, like a decline drop, okay? So a 30-foot drop in this problem is talking about straight down 30 feet, okay? It'll make more sense once you have the triangles in front of you, but it's all, the words in the problem says drops 30 feet. That's all that it says. But it means dropping straight down, not drop it. Because I could interpret this as a drop. It's a decline, right? It's dropping, but that's not what it means, okay? It is talking about 30 feet down, okay? So grab a hold of that, put it on the shelf till you need it tomorrow. So that's pretty much everything over the quiz. So we're going to work through some of these problems on review 8.5. Again, because it's a review and some of these concepts are pretty old, and I certainly don't mind doing a couple with you. So I looked over them and picked what I thought were the most complex ones. So let's just do a couple of them together until we run out of time. So on the first 4, okay, the first section, review 8.5 on page 412, that's where we're at. So in the first 4 problems, the directions say to solve by substitution and then check the solution, okay? So we have two equations with two variables, and we're solving for both variables. And we've learned several different methods for finding these x's and these y's. We actually, right before the Rona hit, we were doing three equations with three unknowns, x, y, and z. We didn't really get to follow up on that because of everything that happened, but just doing the two equations with the two unknowns is pretty basic, and we did it quite a bit. So, but again, it was a long time ago. So let's do number 2. So when we're doing substitution method, what we want to do is, if any of our variables already don't have a coefficient and is positive, that absolutely would be the first one that we would go to, because there's very little work to be done in order to isolate that variable, okay? We don't have that. All of our variables have coefficients with them. Sorry, I have like a really pounding headache and I can't even think. All of these guys have coefficients. So we're just gonna pick something. It doesn't really matter, especially since in this equation, they're all factors of one another. And in this one, they're all factors of one another. So that's something you could also evaluate. Like to get rid of a coefficient, I know I'm going to have to divide. If dividing by that coefficient is going to create fractions, don't do it. I mean, it's just, why would you do that? You know, avoid fractions if at all possible. So it doesn't really matter, okay? So let's just go with this guy. Let's pick this. And it doesn't really matter. Let's just get x by itself. Okay. So you could have went for this guy. Like you could have gotten this x by itself, and we'll end up in the same place. Okay. Doesn't really matter. But let's just work on getting this x by itself. Okay. So I would probably take this over first and transpose this and then get rid of my coefficient. So this -9 is going to move over and become a +9, and he's going to be joined over there with that 3. Now to get x, I've isolated the term. Now to get rid of the coefficient, I just need to divide everything by -3. So 9 divided by -3 would be -3, and then +3 divided by -3 would be a -1. Okay, so that's what x equals. So I'm going to group it because in my other equation, I'm going to substitute that in for x. Okay, so now this is the one that I just worked with. So I'm going to plug this -3y minus 1, since that equals x, I'm going to plug it in right here with the second one. Okay, so all this is this, but with -3y minus 1 substituted in for x. That's why it's called the substitution method. Okay, so now we're going to distribute. We're going to distribute that 2 through and get rid of these parentheses. 6y minus 2. This is just really basic algebra, so these are like terms that I'm going to combine. 8 minus 6 is 2y. I'm going to take that negative 2, I'm going to move him over, he's going to become positive. And when I combine him with a negative 4, that's going to leave me with a negative 2. Okay, I just did a lot of steps in one, but I'm willing to bet you guys can follow because this is pretty old stuff. Okay, so now I just divide both sides by 2. So y equals negative 1. So there's one part of my answer. Now, make sure that you stick that negative 1 in the right spot, okay? Just because it's the first one that we found doesn't mean that it goes first, right? My x goes first and then my y. So be sure that you stick that one there, okay? Now that I know what y equals, I can go back up to one of my originals, okay? Always use an original when you're doing this. You don't want to use something that you did because you might have done something wrong, okay? So always use an original. So we're going to take this negative 1 and we're going to plug it into either one. It doesn't matter, okay? I'm plugging in an x and I'm solving for y. I'm plugging in a y and I'm solving for x. So I would personally plug it into this one simply because my x is positive already, and that's just one less step that I have to do, okay? So I'm going to take this equation, and for y, I can now plug in negative 1. And that will leave me with just one variable left, x, which is exactly what we need. So I've got 2x, positive 1 times negative 8 is negative 8. So I take that negative 8, I move him over, he becomes positive. 8 minus 4 is 4, divide both sides by 2. X equals 2. Now, we're going to check them because they have to work in both, okay? So let's check. So I've got negative 3, and then in place of the x, I'm going to substitute in a 2, minus 9 times negative 1 equals 3. So we got to use our order of operations. So this is a negative 6. Negative 9 times negative 1 is a positive 9. 6 minus 9 does equal 3, so that one checks out. This one's good. All right, now this one, 2 times, instead of an x, we're going to put in a 2, plus 8, and instead of a y, we're going to substitute in a negative 1, equals negative 4. So let's see if this one checks. 2 times 2 is 4. Positive 8 times negative 1 is a negative 8. 4 minus 8 does indeed equal a negative 4. So we know this is the correct answer. We know that for a fact. No guessing, no wondering. You know it works. You know it's true. So let's see. The next section of problems, let's read those directions. Solve by elimination. Okay, the elimination method can also be called the addition method. It's the same thing, but I usually refer to it as the addition method. And check the solution. If there are any infinite number of solutions, write the answer as an ordered pair of terms with the parameter of t. And we did that, but I'm just going to go ahead and do you a favor and tell you there aren't any. So none of these will have t's in the answer, but we did do that. this year. We had to give it parameters. So let's do one of these together. Let's do number 8. Okay, let's see. Okay, so the addition method or the elimination method is when we are trying to get either x or y to disappear, to when we combine them, that they combine to 0, that one of them gets eliminated, however you want to look at it. So what we're trying, so in order for that to happen, so we're looking at this in terms of columns. That's why it's situated like it is. So we've got an x column, a y column, and then our constants are there in a column. So we've got to get either x or y to be eliminated, all right? So in order for that to happen, whichever one you do first, it doesn't matter, the coefficients have to be exactly the same number, but the signs have to be opposite in order for them to cancel whenever we combine them. Like if I just combined these like it is, I'm going to get a negative x. So that doesn't disappear. If I were to combine these, I'd end up with 3 y's. That doesn't help, okay? So your strategy would be, if you can find either an x or y that already has opposite signs, go with that. Okay, that's one less thing that you have to do. If you can get 6 to eliminate with 9 by just multiplying one of them, you would do that, but you can't do that. I can't multiply 6 by anything to get a 9. I can't easily get 2 to a 3, okay? So we're obviously going to have to multiply both equations by something, all right? So at that point, it doesn't really matter. You can stick with smaller numbers. It really is just a matter of preference. So I can multiply this by a 3, giving me a 6x, and then I can multiply the bottom one with a 2, giving me a negative 6x, and those would cancel. Or I could multiply the top one by a 2 to give me an 18y, and multiply the bottom with a 3, giving me a negative 18y. So again, it doesn't really matter. It's whatever you prefer, whatever you like. So probably let's just do, let's do the harder one. So I'm going to multiply the top by a 2 and the bottom by a 3. Okay? So what that's going to do is give me a positive 18y and a negative 18y. Okay, so once I distribute those, my y's are going to cancel. Okay, so you could have done the 2 and the 3, and that would have been fine. You would have just found y first instead of x, but no big deal. They both have to be found. All right, so let's distribute these. Okay. So once I distributed these two numbers, you can see that when I combine my columns, my y's are going to be gone. My y's are going to be eliminated. That's why they call it the elimination. It's called the addition method because we're combining terms. But anyway, so when I combine or add or whatever my x terms, I have -5 of them. My y's are gone, just like they're supposed to be. That was the whole purpose of us doing that. And then when I combine my constants over here, there is 0. -24 plus 24 is 0. So to get x by itself, I would divide both sides by -5. So x equals 0, right? So that's the first one. I happen to find x first, okay? So now we have to find y. So now we take 0 and we go back to one of our originals, okay? And we're going to plug 0 in for an x, and then we're going to solve for y. So it doesn't matter. I would pick this one only because my y term is already positive. So again, that's just one less step that I would have to do. So let's take this one. I'm going to use the first one. So this is that first equation, but instead of an x, I've now substituted in that 0. So that leaves me with just 9y on the left, because 2 times 0 is 0. And then I divide both sides by 9. So this would be 4, 12. 3 goes into 12 4 times. 3 goes into 9 3 times. So y is -4/3. And then check them, plug them in here. Do we have time? Yeah. I'll let you go. I'll let you do that. Make sure that you check them because they have to work for both, okay? So take your original, substitute 0 in here, -4/3 in here, okay? Your calculator can handle all the fraction stuff. Make sure that that's true. And then take this one, plug in 0, plug in -4/3, check it, make sure that it is a true statement. Okay, the next two, the instructions say, find the values for the other two basic trig functions for angle theta using the given trig function information. Leave answers as exact values. All right, so some of you guys had a hard time with problems like these, and I think it's simply from not reading your directions, because there was, I don't know if it was another review or something, you had problems like 9 and 10 with the same exact instructions, but yet the answers that you turned in were just decimal numbers. Like you gave me, I don't know what you did. I don't know if you thought it was the angle. I don't know. It was kind of bizarre. But you didn't show me anything, so I don't know what you did. But these instructions say to find the other two basic trig functions. So I'm given sine. I have to find cosine and tangent. That's what that means. Find the other two. Yes?
Brian won't know if you check them separately.
Yes. Yeah, they both have to work. Mm-hmm. They both have to be true. In order for you to say that this is your answer, it has to be true for both. Okay, so let's talk about number 9. So this is the information that we've been given. the sine of theta equals 2 over 3. So, and again, the directions say find the other two, okay? The other two trig functions are cosine and tangent. That's what we have to find, okay? So let's piece together, I know that sine equals opposite over hypotenuse. So I can get this 2 and this 3 situated, okay? I have to assign theta to one of these acute angles. It doesn't matter which one. It's all going to work out in the wash, all going to come out in the wash, okay? So I'll just call this one theta. All right? So if sine is opposite over hypotenuse, that means that in relation to this, my opposite is 2 and my hypotenuse is 3. Okay, so we're just having to put pieces of the puzzle together. Cosine, I know, is adjacent over hypotenuse, and tangent is opposite. I just wrote what I said. Tangent is opposite over adjacent. So what I'm missing here is adjacent. So in order to figure out what that is, I would use the Pythagorean theorem. So doesn't matter. We can call this A. So A squared plus, if this is A, then this has to be B, because the hypotenuse is always C. So I take that 4, he becomes negative. That's 5. So A equals the square root of 5. So now I know adjacent. So now it's just a matter of plugging in the values, okay? So adjacent is square root of 5 over hypotenuse, which is 3. Tangent, opposite, is 2 over adjacent. Okay. Some of you guys are leaving your answers like this, but that's not acceptable because we are not allowed to have a radical in the denominator. So you're not done. And your calculator will rationalize your denominator for you, okay? So it's easy, you're just stopping too soon, okay? This is not the right answer, okay? This is not allowed. So I have to rationalize the denominator. So that's your answer. That's your final answer. So there we just found the other two trig functions, okay? So you'll do 10 just like you did 9. And on 11 and 12, let's read the directions. Find the value of each trig function using the given angle and a calculator round to 3 decimal places. So the hardest thing about this for you is following instructions on rounding, okay? Round to 3 decimal places. I've just kind of scratched the surface of some of y'all's grading from the stuff that you turned in this week. And some of you guys still aren't rounding. You're not rounding to the right place or you're not rounding properly. Okay, so you're going to get some deduction from that. Okay, I may not count the whole thing off, but you're going to get docked some points for either not rounding to the place that it tells you to round, that your directions tell you to round to. You have to follow directions, or if you're rounding incorrectly. All right. So that's just a matter of punching it into your calculator, okay? You're not shifting anything. You're not looking for an angle. An angle's been given. You got 80 degrees and 128 degrees. So this is just as simple as punching this into your calculator. Tangent of 80 equals and you're going to give me the answer with the right number of digits in it, okay? So that should get you through that review. Since I did have time to go over tomorrow's quiz, we won't need to meet here tomorrow, and we will meet on Friday, just to kind of walk through this chapter 8 review. So here's my request for you. Before 8:05 on Friday, look over this review and just see if you have any questions, okay? All we're going to do for the rest of the week is the review this review right here that we were working on. You've got a quiz tomorrow. I've already gone over it. And we're going to meet together on Friday to go over the chapter review. The only thing that you're going to have to do next week is a chapter test. That's it. Yes?
I want to know if you can explain the equal sign and squiggly equal sign rule again.
Okay. When you get the first answer in your calculator with the long decimal sign, with the long decimal string of numbers, that's an equal because that's an exact answer. When you round, that is when you use the squiggly lines. That means approximately. Okay. This is for rounded numbers. This is for exact numbers. Okay. These are the long decimal, the long string of numbers behind your decimal. Okay. Okay, so Friday morning, if you will just before we meet together, look over this just to see if you have any questions. And what I'll come in for on Friday is just to answer any questions that you have about the review, okay? The review is what you're going to do to prepare yourself for the test, okay? And then you'll take this chapter 8 test next week, and then we're done. We're done for the year, okay? So that's all I've got. If you don't have any more questions, then we're gonna wrap it up. So I'll give you guys just a minute. So I'm not planning on, just so you know, I'm not planning on doing that entire chapter review with you. So I'm just here to answer questions, okay? So you do your due diligence in looking over it ahead of time and come to class with questions on Friday. And if you don't come to class, then you don't have the luxury of asking any questions. All right, I guess everybody's good. All right, see you Friday.